Hey guys, Mr. B here. In this video we're going to be going over the questions in chapter 9.1. So if you had any confusion or weren't sure what the answers were, hopefully this video will help you. Alright, so number one, it says metallic elements tend to blank electrons. We learned this in chapter 7, but metallic elements tend to lose electrons, whereas non-metallic elements tend to gain electrons. Number two, the charge of a group A non-metal ion is determined by subtracting blank from the group number. This is 8. So you can figure out the charge of any group A non-metal. Group A means any column that is not in the middle, so not the transition elements, and non-metals are elements that are on the right side of the periodic table. So groups 5, 6, or 7. Just take 8, subtract that column number, and that will tell you what charge they make. So elements in column 7 will make a charge of -1. So 8 minus 7 is 1, and vice versa. Same with the other ones. So number 3, what is the charge on the ion typically formed by each element? Okay, so for oxygen, oxygen is going to make a charge of -2. This also can be found in the slides here. So there's this nice little chart, and it gives you the charges for all these different elements. Oxygen in column 6, all elements in column 6 make a charge of 2-. So oxygen is going to be 2-. Iodine in column 7, again, we can look back on this chart, makes a charge of -1. So we'll put -1 or 1-, whichever one you want to do. And then sodium being in column 1 on the periodic table, it makes a charge of +1. So this is going to be 1+. Okay. Number 4, it says name the ions formed by these elements and classify them as anions or cations. All right. So I think we're going to need to insert a text box here so that we can actually type. So I'm just going to insert a text box. Okay. So for A, selenium, the ions formed by these elements, selenium is going to be in column 6. Again, it's on this chart. It makes a charge of 2- when it becomes an ion. So naming them wise, selenium will be Se, and make sure we use the right thing here to get our superscript. Might be format options, text. There you go, superscript. Okay, so Se 2-. It is an anion because it's negative, and when we name this, because it's an anion, we have to change the ending. So this is going to be called a selenide ion. Remember that negative ions, anions, have to have that "ide" ending on the end of them. So we do have to put that on there. For B, barium is in column 2 on the periodic table, so it makes a charge of 2+. So for barium, this will be Ba 2+. It is a cation because it is positive, and because it's a cation, we don't need to change anything about its name, so we would just call this a barium ion. There does not need to be an "ide" ending. That is only for negative ones. And then for letter C, phosphorus. Again, phosphorus is on this chart. It makes a charge of 3-. So we will have P3-. This is an anion, and because it is an anion, we need to change the ending to "ide." So rather than calling this a phosphorus ion, we would call it a phosphide ion. All right, looking at number 5. Name each ion, identify as a cation or anion. All right, so we're basically doing the same exact thing that we just did on the previous problem, just for different ones. So Sn2+. So this is tin. Tin is a transition metal. It makes more than one charge, which means that we do need to have a Roman numeral that indicates the charge. So we would not just call this a tin ion because we need to make note of what the charge is. The charge in this case is 2+, so in parentheses we're going to put 2 capital I's for Roman numeral 2 and call this a tin2 ion. For letter B, Br-, that is bromine. I realized we did not identify this as a cation or an anion. This is a cation because it is positive. Br is bromine. because it is a negative ion, we have to have that "-ide" ending, bromide. We do not need to have a Roman numeral because it's not a transition metal. It only makes one charge. The only time you have to have a Roman numeral is when you have an element that makes more than one charge, and bromine doesn't make more than one. It only makes -1. So we're going to call this bromide ion, and it is an anion because it is negative. Letter C, K+, that is potassium. We are just going to call this a potassium ion. Potassium is not a transition metal. It is not in the middle of the periodic table. It doesn't make more than one charge. It only makes a charge of +1, so we do not need to have a Roman numeral for it. And because it's positive, we don't need to have the "-ide" ending. That "-ide" ending is only for negative ions. And then letter D, this is manganese. Manganese is a transition metal. It is in the middle of the periodic table. It makes more than one charge, so we do need to have a Roman numeral indicating the charge. In this case, it's going to be a 2. So this would be manganese 2 ion, and then because it is positive, it is a cation. Again, there's no "-ide" ending on it because it is not negative. All right, looking at the last ones here then, for number 6, write the formula including charge for each ion. So carbonate, that is a polyatomic ion that can be found on the back of your periodic table. It has a formula of CO3 and a charge of 2-. So we would just write CO3, 2-. I know all the shortcuts for doing the little numbers and the big numbers up top, subscripts and superscripts. But if you don't know how to do that, if you go to Format Text, you can click on Superscript. The shortcut even shows you here, you hit Control and then period or Control and comma, and that will make the numbers be either big ones up top or little ones down below or whatever. So, for letter B, a nitrite ion, that is another polyatomic ion. It's on the back of your periodic table. It has a formula of NO2 -1. We don't need to put the -1, we can just put minus. So the 1 is just indicated there or assumed that it's there. And then sulfate, again, another polyatomic ion, has a chemical formula of SO4 and a charge of 2-. So that's what they're looking for that one. And then number 7, last question here. Name the following ions. Identify each as a cation or an anion. So Cn-, that is a polyatomic ion. It is on the back of your periodic table. It is called cyanide. So that is a cyanide ion. And it is an anion because it is negative. So we're going to write anion. For letter B, HCO3-. This actually has 2 different names. On the back of your periodic table, it is on there, and it's called a hydrogen carbonate ion. But it also has a name of bicarbonate. So, like that. Actually, you know what? Let's reformat this so it looks better. Let's copy this, and we will just paste it down below here. So let's do like that. Okay. So it is. It's called hydrogen carbonate ion. Another name for it is bicarbonate. And because it is negatively charged, it is an anion. Okay. So hydrogen carbonate or bicarbonate, it's the same thing. It's just 2 different ways of naming it. So if you're confused on that, it's just another way we call it. So you'll notice other ones on the back of your sheet on your polyatomic ion list that have the same thing. For letter C, PO4 3-, that is called a phosphate ion. That also is a polyatomic ion on the back of your periodic table. It is an anion because it is negatively charged. And then last one, letter D, Ca2+ is calcium. We call this a calcium ion. It is positively charged, so it doesn't have that "-ide" ending. That "-ide" ending is only put on regular elements that are negatively charged ions. This is a positively charged one, so we don't have to have the "-ide" ending. It's called calcium ion, and then because it is positive, it is a cation. So, all right, hopefully it helps you. Again, if you have any other questions, you can always email me and let me know. Okay, see you in the next video.